back with another 7 Caillou challenge. This one's called Breaking Chocolate Problem. Your task is to split the chocolate bar of given dimensions n by m into small squares. Each square is of size 1 by 1 and unbreakable. Implement a function that will return the minimum number of breaks needed. For example, if you are given a chocolate bar of size 2 by 1, you can split it to single squares in just one break, but for size 3 by 1, you must do 2 breaks. If input data is invalid, you should return 0, as in no breaks are needed if we do not have any chocolate to split. Input will always be a non-negative integer. That's weird that they would say it's always a non-negative integer and then kind of in the previous sentence say if input data is invalid. They kind of open the door that it could be invalid. So since they're not clear about that, let's assume that data can be invalid. And that's the best thing to do anyways. That's what you're going to do in real life. So go ahead and pause this. It's entirely within your abilities to solve this, and then come back when you're ready. So I'm going to handle that invalid input situation first. So I'm going to say if n is less than or equal to 0, right? That's sort of like gibberish in this problem. It doesn't make sense to have a 0 width or a 0 length, or certainly a -3 length or width. That's nonsensical. Or m, it's either dimension, right? If either one of those is invalid, the whole problem's kind of off, right? You could have a perfectly valid value for one of the dimensions, and that doesn't help if the other one's 0. So in this case, I'm just going to say what the problem told us to do, return 0. Okay. And then finally, it's kind of helpful if you imagine like you have a Hershey bar. You know how they have the little squares within, let's say, Hershey on them. They're kind of sub-rectangles of the overall rectangular chocolate bar. And so you could imagine you have one of these, but imagine they can come in various sizes. So 2 by 3, right? 2 rows, 3 columns. And then just think of how many breaks it takes. In that case, you get 1 break to break it in half, right? And then you're kind of left with 2 rows of 3 rectangles. And then it should be clear for each of those rectangles, they're going to be 2 breaks, right? You break one rectangle off, and then another rectangle off, and you've got 3 rectangles. So you had 2 breaks for each of those rows, plus the 1 to split it in half. That sums up to 5. And so if you do this with other dimensions like 3 by 5, etc., you kind of notice a pattern. And then I simply returned n times m minus 1. Sort of the number of squares minus 1. Then I'll run my test. Looks good. Looks good. So yeah, not too bad there. You just kind of had to visualize how this would go, breaking up the chocolate. So hopefully that one was pretty easy for you, but as always, contact me with questions or concerns. Otherwise, we'll keep moving. Go ahead and submit, collect our points. I don't imagine there's much to glean from looking at the other solutions, but it doesn't hurt, right, to take a quick scan. So go ahead and do that too. See you in the next video.